was the question actually arising. We know that diagonalization of a matrix A is equal to P D T inverse, where P is the invertible matrix, which includes eigenvectors as columns, and D is the diagonal matrix whose diagonal elements are eigenvalues. See, A power n means for this case P D power n P inverse. This is actually the manually how we have to find easily the maximum power of the matrix A. D power n. But how do you verify in the MATLAB? That was the question raised by one of the participants. Actually here A, actually I typed here. So this is the A matrix. Now find what is invertible matrix P and diagonal matrix D is equal to, using the syntax EAG of A. Yesterday we discussed this. So this is what is the diagonal matrix, and this is the invertible matrix. This is the invertible matrix P. See, if you would like to find A square, simply the A square, it is 5, 12, 18, 14, 25, 42, 36, 54, 90. But using that formula, P star D square star inverse of P. I got the same. It is a 5 plus 0 into I. 0 into I is nothing but 0. There is no imaginary part. Don't get confused with this. That output is appearing like this. 5 plus 0 into I is nothing but a 5 itself. 12 plus 0 into I is nothing but 12 itself. Similarly, 18 minus 0, I is nothing but 18 itself. This is 5, 12, 18. So similarly, suppose the last four, 36, 54, 90. 36, 54, 90, like that, whatever the maximum power. So that is the actual procedure. But using this, in a single syntax, you can find easily whatever the maximum power of it. Now, actually, let us come to the today's session. In this today's lecture, I plan to cover 2D and 3D plots, and how do you solve differential equations in various techniques. I mean, what are the various methods available, and how do you find using MATLAB. So these are the various types. How do you visualize any function or any data according to our requirements? Suppose the line plots, data distribution plots, like this. If suppose we have a data, it just like suppose a statistical point of view, or suppose we know the age of certain people. How do you decide what is the mean, what is the median? How do you check how the age has been distributed over certain area? I mean, what is the minimum, what is the maximum? Graphically, how do you visualize? So like that, discrete data points. Geographical plots is nothing but suppose you would like to in Bangalore, suppose in certain area, a certain period. Of course, we have seen in COVID-19 related statistical data. Graphically, we are seeing in the website, right? But how those can be visualized? It simply suppose background is a geographical plot, and over that we should specify particularly which area is the maximum. So that area should be filled by certain color, and we should give the hint that this color related region is the red region. Don't go there. So like that, we should give the instructions to the people. So like that, actually, those graphs are visualized. How those can be visualized? Geographical and polar plots, contour plots. The contour plots can be utilized for 2D and 3D. The function is in terms of 2 variables and 3 variables. How you can make the contours? What about vector fields? What about the streamlines? Maybe the fluid or temperature over the surface. Yeah, if you take the plate, over the plate, how the heat is distributing. Graphically, how do you show it? Using a streamlines or vector fields. And next, the surfaces, volumes, and polygons and animation. I think the last two I'm not sure to cover this, but the remaining I'll try to cover, and I'll try to give the complete, I mean, maximum information what I have known. Let us go to the line plots. What are the various syntaxes to draw the 2D and 3D line plots? One is PLOT, and 3D means PLOT3, states error bar. So that means suppose you found any numerical solution of certain function, but you know exact what is the difference of that, what is the error you are getting. So using this, we can easily compare what is the error. I mean, at each point, what is the error? We can easily visualize uh, to define how much accuracy we are getting. Next, log plots also we can use to verify the error of certain numerical techniques. And function plots. Uh, that means suppose we know exactly certain expression. How do you visualize that expression? Maybe that is in 2D or 3D expression. Or suppose the expression may be implicit. What is mean by implicit means usually we know that y is equal to f of x, is right. So these we can call it as actually explicit. But what is mean by implicit means we can't write in terms of this form y is equal to f of x. That means the expression should be like this, or the constant maybe. It is just like y square plus 2xy plus y square is equal to 4. So these, sorry, it is x square y square. It is a little difficult to write y is in terms of only in terms of expression. So that's why these type of function you can call it as simple. So those we see how it is. What about line plots? Plot. See, the syntax is while I'll show one by one. I think that is the better for you using the MATLAB software. Let me take the script file, or course live script also, no problem. Yeah, let me take. So this is the live script. Now plotting line plots. Okay. So for these, we need to get certain x values and certain y values. So for that, let us take the x value. Suppose x is equal to 0 to 1. Okay, so this is one way of assigning a vector 0 to 1, or I'll give various forms 0 to 1, or if you'd like to specify 0, 0 0.2, 0 0.4, 0 0.6, 0 0.8, and 1. This is one format. Or if you'd like to give only 0 to 1. See, let us see what is the output of this. X is equal to 0 to 1. We are getting 0 and 1, only the two elements. So that means, observe here this symbol, this colon symbol actually gives only one increment, but you would like to make the 0.2 step size for that. So then that you can give like this, 0, 0, every time 0 point step size. Now let us see what, see, observe here, 0, 0 0.2, 0 0.2, 0 0.4, 0 0.6, 0 0.8, and 1. Or if you'd like to increase also, you can increase 0 0.1, suppose 0 0.1, like that. Now I don't want to exclude this x value. Next, suppose y is equal to, let me take the simple function sin x, because we know the what is the behavior of a sin x, is right. So that's why whatever you are going to try the new thing, try to implement for the known things, known concepts, by which you can use, you can easily verify whether it is giving you a right result or not. So that's why we are starting with the basic concept sin x. Suppose, see here, sin x values at every point x and y. This is sin x. Now plot x comma y. This is plot x comma y. So this is the syntax plot of x comma y. Now let me run this. Control enter is the option. I mean the keyword to execute this file. So that's why I'm using. This is a plot of x comma y. Let us see how it is showing plot of x comma y. See here 0 to 1. This is it's coming like this. Okay. So we know that actually in if we are not specifying x, then by default it will take the x inside of the sin x. I mean trigonometric expression, radians. 0 to 1 radians is coming like this. So that's why let us make suppose 0 to pi, or let me take 2 times of pi. That much better to get complete behavior of a sine. Plot of x comma y. See here the plot of x comma y. Okay, but the same thing, suppose you would like to execute in a script file, the same thing you copy, the same thing you copy, and it will, so this, yeah, this is, let me run day 3 tutorial, suppose day 3 tutorial. Now you once you run this, it will show the another file. See, this is the file you are getting like this. See, if you would like to zoom, observe here the right, top right. Once you move the cursor like this, now there are zoom option. Once you click on that, just wherever you would like to zoom it out, you can zoom it like that. Wherever you would like to zoom it out, you can zoom it. Or if you come back, then click on zoom out, and zoom out. Just that's all. So this is a general graph is right. Now here the thing is, what is the x-axis, what is the y-axis? You would like to specify. And what about this curve? What this curve represents, either sin x or cos x, what it may be. Or you'd like to make different colors for this curve, or a different alignment of this plot. So what are the options for that? What are the options to draw the different colors? See, for the same syntax, plot of x comma y, simply use in between single quotes. If you mention, suppose k, this is the k, suppose. Just see the curve, it is in black, right? Suppose you'd like to make it in red color. Yes, red. This is red. Or you'd like to change the style. I don't want solid line. Suppose the dotted lines. See, now it is dotted lines. But both you have to make it up. The color should be the red, and plot's style to be dotted line. So that's why for that, simply just make the combination like this. This all information is available in the MATLAB website. We can't make it whatever we want. Whatever available there, those we have to use it. So now see here the style how it should be. See, this is. See, if you are using a dotted lines, the thickness is not visible properly. Suppose if you feel, how should you increase? The simply comma, simply put 2. Then next. I'm sorry. We should write line width, the curve line width. Suppose that 2. See what it is. Is it increasing the thickness? Right. So both will appear immediately. You see what changes. Suppose I would like to make it the green. Suppose green, you can make it into the green. Say green. Or you would like to increase the size. Suppose the 3. See, it is increased. or you'd like to change the style. This is one of the formats. So this, or if you'd like to make, sorry, dots, you can make. Or you don't want to the line, you want only circles. Circles. Let us see. Yeah, only the circles. At every point, circles will appear. Or if you want to make the plus, that will appear. So if you want to make the greater than, suppose at every point, that will show the greater than. So whatever the options available, see to increase the size of line width and the colors, there are various. I'll show you. I think I made a PPT for that. See, these are the different styles available to use in a MATLAB: solid line, dashed line, dotted line, and dash dot lines. These are the styles. So any combination if you want, you can take. Next, the colors. So these are the colors: yellow, magenta, cyan, red, green, blue, white, and black. These are the available color formats available here. And see the styles, whatever you want, like the circle, just now I've shown you the plus, asterisk, and point. If you want to visualize at every nodal point, you can make it, or the cross means simply x, square means you take the s value like that. So these are the options, what type of styles you want to visualize. Now the question is, I would like to visualize both sine and cos in a same graph. Sorry, let us move first. How do you make the grid for that? Grid on, simply. See, this is a format, right? Let us move to simply the solid one. This is the grid. Observe here, lines are coming, vertical and horizontal lines at every step size. Is right? This is 1, 2, 3, 4, 5, 6, and here -1, -0 point, -1 to 1, in between -1 to 1. Okay, so this is next. Suppose I would like to make the x label. X label. The syntax is x-axis itself simply, and y label. Simply, I would like to make the y. Yeah, just run it. Observe here, it is the x is appearing in the graph, and y is appearing in the graph. This is x is appearing and y is appearing. But how do you increase text size in x label and y label? That is also important, right? So see, this is x means here the font size. Font size, if you want 20, the same thing you can use for this. Here x and y, or if you'd like to make the bold, /bf, bold font. X and y are in bold format, or if you want italic, you can use bi or something else. There are various syntaxes, whatever you'd like to wish to execute. But I would like to make a title for this. Suppose title syntax is title sin x graph, or graph of sin x. Simply, it is in between single quotes. Just execute. Now see, graph of sin x. The top it is up here. Graph of sin x. Is right. X label, y label. How to generate a grid? What about the title or something? We'll see. Suppose while you are writing a code and running this, maybe the graph is appearing like this, but sometimes you would like to visualize beyond the required range. It's actually, it is appearing from -1 to 1. Is right. Let us make it -2, 2. I mean, for the visualization. For that, how do you restrict x and y range? Axis. Suppose here it is appearing 0 to 2 pi, right? Let me take minus pi to 3 pi, suppose. This is the x range. The first one is minimum value of x, the second is the maximum value of x. Okay, next, minimum and maximum of y value, suppose this is like this. Now keep observe the graph, what changes we can see. Only axis we are changing. See here, this is earlier it is -1, now it is -2. Earlier it is 1, now it is 2. But this is actually from here earlier 0 to 7 something, but for this case it is minus pi to 3 pi. So this is how do you change the axis, either the minimize or the maximize, wherever you want to visualize of the graph. That is also you can easily give the restrictions using this axis code. This is. But see, suppose I would like to show this sin x. If suppose there are multiple curves and each curve will represent in a different color and different style. But how do you make the title properly? So that means by looking at the graph, we are able to identify which curve represents what exactly. So for that, we use the legend option. Legend. What is the curve? Actually, this is the sin x. Is right? This is the sin x. Just feel it, what it is. You see, observe here. This is, so the red color curve is nothing but the sin x. Let me draw the multiple curves. Let me draw the multiple curves. Suppose this is y1. Let me take this in the syntax also y1. Next, y2 is equal to suppose cos x. Let me take the same 0 to 2 pi I only. Y2 is equal to cos x. Here x y1 is equal to minus or line width 3, right? I see. Let us restrict this. Let me take a plot x comma y2, suppose. Let me draw using this syntax. See what it is appearing. The first one is not displaying here. Only the second plot syntax is displaying. So that means whatever the final most syntax that will generate to execute the file. But what is our aim? To visualize these two in a single graph. So what are the possibilities? So that means the first one we don't want to delete it. That's why we hold on that plot. That's why hold on. That is the syntax for that. Next, then you can run this file. Both will be appear. See, the both graphs are visible here. But which curve represents what? That we should make it up clearly, right? The remaining one by one, the grid label, the X label, and Y label, and the title is not suitable actually. That's why I'll remove it. Or if you want to make it clear, graphs of sine and cos. If you want, you can write here. Sine, graphs of sine x and cos x. Now come to the legend. Sine x comma cos x. Exactly what curve represents what, that will give the legend option. These two. But see, like whatever we are giving, the same syntax let us give for another one. See, this is. Now let me take suppose blue color, and I'll change the style also. Now see here, I run the x and y axis files. The same curve we have drawn, so that's why it is. Let me close and redraw. Then you will get a new curve. See, like this. Is right. So this is the new curve. See, observe the sine of x and cos of x. So that means whatever the multiple curves, how you can easily visualize this. See, suppose you'd like this is not your wish. I mean, you don't want to show the graphs in a single axis, single graph sheet. Suppose you'd like to take the different sheets and in a single graph window you should like to visualize them. So for that, let us go for the subplots. Subplots. Okay. So subplot syntax is, observe here, the subplot syntax is, actually here it is. Yeah. See, subplot of m comma n comma p. Okay. So this is the syntax actually. M represents how many number of rows you would like to, I mean, it is just like a matrix format. Let me give the clarity regarding this. Suppose actually this is the graph. Here you would like to make one graph. Here you would like to make one graph. Here you would like to make one graph. Here you would like to visualize one graph. Is right? So this is like A11, A12, A21, A22. Is that the same way? While you are assigning the subplot syntax, you have to give this is let me take 2 comma 2. Now first 2 represents number of rows, second position represents number of columns. Now in which element you would like to show this, that's why 1. Okay, the same syntax let me take for the second one like this, subplot 2 comma 2 comma 2. Now let me run this. See here. Why this X label, Y label, title, legend are appearing only for the second curve? Because for the first curve we have not assigned anything. So that means again you copy all these things like this. Yeah. Now you run this file, then feel what it is. Yes. Maybe in the legend it is showing the error, so that's why it's coming like this. Oh, again we copied in the same position, right? Sorry for that. So after the subplot, X and Y, and whatever the grid, the red color, the sign X is not visible properly. For these we make the legend, so that's why it's coming like that. Here you remove the legend. So there are various options, but the thing is you should learn what is the MATLAB language to visualize properly. So that is the format. So this is how do you plot a simple graph, whatever it is, what are the options for the X label, Y label, whatever the title, or whatever the legend, how do you do it? So this is a very simple. Now see, the main question is how do you save the file? That is also must and should, right? So that means, see, if you go to the file, there are the options. Save the file, save as. Save means, let us see what are the formats available for this. Once you suppose a sample graph, or let me take sine cos graph, and see what are the formats available. MATLAB figure. So that means you can't open in a JPG file or any other formats is not possible to open once you save the file in MATLAB figure. So this can be opened using the MATLAB software itself. Next, bitmap, EPS files. Most of the time to publish, in journals, to write up any journals, research papers, the people are using EPS files. EPS files easily can executable by LaTeX software. That is a documentation. Enhanced meta file, JPEG. There are various formats in which you would like to save the file and reuse those, the graphs. Suppose I will save the file in JPEG format, suppose. Yes. Now I will close it and let me go to the folder. So this is the folder actually. Now let me open the same file. Now it will appear like this. See here, it is taking time to visualize this. See, this is the graph. And you can easily copy in Word document. Suppose, let me take the Word file and simply you copy this graph, right click and copy. Is right? Yes. Let me take the new document and simply paste it. That's all. So this is how you save the plot easily. And the resolution also doesn't change here. Whatever the resolution appearing through MATLAB, converting in terms of JPEG, so like that, if you convert in terms of EPS and to execute through LaTeX software, the resolution appears more nicely than this one. So that is the advantage of converting into EPS and execute those using a LaTeX. But of course, this visuality, as per the requirements, you can use the options, whatever the available options. Okay, but observe here in this slide, actually it is showing the plot multiple curves option in the single syntax itself. It is given. See, the 3 curves is right, xy1, xy2, xy3. So this is also another possibility. Plot of xy1, let us go for that. Suppose this is the thing, right? Let me, yeah, till here, let me block this. I want to use a single syntax, plot x comma y1. For this, I would like to make the red color solid line. Next, x y2. Okay, and for this, I would like to give a blue. I mean, a style also. I would like to change it. Next, let me take suppose the third curve, but we have not defined here. But let us define that. That is not a problem. This is right. Let me take y3 is equal to tan of x. Is right. Now run the file and see what it is getting. See here, because the tan x range is maximum, right? So that's why it is appearing like this. Now for this case, you feel the requirement of making the axis. Is right, 0 to 2 pi, and the range is suppose that should be maximum -3 to 3 is enough, I think. Yeah. Yes. See also. 0 y3 in between that -3 comma 3, it's not visible. Let us take that 10 minus 10. Oh, sorry. Green color is not visible properly. That's why it is. Let me take the line width. Suppose 3. Yeah. Then let me restrict to -3 to 3 of y-axis. Yes. Now you feel the 3 is right. The red one is a sine and the blue is the cos x. And the green is the tan x curve. So this is in a single syntax. How do you draw the multiples? But the subplots, if you want to use the subplots, means you continue with this syntax itself. In a single syntax is not possible. For every syntax, there is an advantage and disadvantage. But how we want, so such a way we should utilize and we should execute this. So this is the line plots complete structure, right? But see, suppose at the time of representation here, actually the step 0, 1, 2, 3, 4, 5, 6, right? Go to the view, property editor. Once you click on the property editor, that graphical window will appear in a different format. See here, this is. Observe here the property editor. This is the property editor axis. Okay. So whatever you have not given earlier, see here, if you'd like to give the title, you can give. And you'd like to assign the X label, you can assign the X label here. Okay. Actually here X label 0 to 6.28, right? You can give here itself -1 to something +7. Here X scale is the linear. Right? If you'd like to make it a quadratic, you can give. But x-axis location is the bottom. If you'd like to change the formats y x x as x labels as y and y label as x, if you want to interchange also you can interchange. And see, you don't want to make the box for this like this. Don't want to make the box for this graph. Okay, simply by unchecking this, you can easily remove that box. Okay, so let us try all these options one by one. See here, title if you want to give trigonometric graphs. See, once I'm typing, there it is appearing here. Is right? Trigonometric curves. X label, capital X. Once it is appearing. Now I would like to take the y-axis. Suppose y. Is right? Now suppose let me change the x values. It is just like a minus pi. Suppose. See what it is. Why here it is not showing the curve means in the coding x values we have taken from 0. So that's why in this negative area it is not showing. But once you take the x values there, definitely it will show. Okay, so let me continue with the 0 itself. Yeah, this is 0. And if you want to make the log file, see what about the log file? Once we make the linear to the log, how it is appearing? The curve format is changing. So like that, there are various options in the property editor. Let me make it a linear itself. This is the standard one. And if you want to increase the font size also, you can easily increase. They actually 9.5. I'll make the 16. Now, by default for x-axis, y-axis, and title, all will change easily. Or if you want to make the different styles for that, if you want, you can change that. So I'll get it. There are different formats here. Suppose usually the people prefer Times New Roman or Arial, whatever it may be. So whatever you want, you can make like that. Whatever you'd like to execute the graph, I mean save the file, you can use the property editor like this also. Or if you know the syntaxes, there itself you can change one by one. In the coding itself, you can change and you can continue. So this simply to save the file, then it's control the sample curves of course. That's all. This is how. What about the lines, line plots, information? Where is my PPT? This is. These are the various options in this. Now let us move to the error files. See these. These are the x values and these are the y values. But actually, we came to know that this is the error. But how do you draw the error file? So actually at every point, I mean at one value, at 10, at 20, at 30, what is the error we are getting? This is how we can visualize. Let us try this one. Then we can move for further. See. So let me take the same. Sorry. So error graph, suppose x is equal to 1 to 100 and y is equal to, it is mentioned 20, 30, 45, 40, sorry, 60, 65, 80 and 70. Total 10 values we need to write, right? 75, 95 and suppose 90 randomly assigned. Now error is equal to, I'm just taking one syntax, whatever this is, size of y. Yeah, now this is the syntax to draw the error curve, x, y and error. Usually xy gives x-axis range and y, I mean the curve. At every point, what is the error, it will show by default like this. Oh, here 7075, so that's why it is here. Let me move it. So actually X and Y size is not proper. That's why it is showing like this. Yeah, here it is. So see at every point what is the error rate? Simply showing, suppose I'll change here 8 times, right? I'll just change 2 times of once. Just feel what difference we are observing here. What is the range here? Or suppose let me take 4 here and see what is the error we are observing there. I mean, in a graph, what changes we are observing there, or if you want to change here, actually 60, 65, 90, right? Let me take a 20, 45, and 55. For these changes, see what it is. So this is one of the technique to visualize the error in the same curve. At certain point, what error we are getting also we are visualizing through this syntax error bar. The next one is another option to visualize like this log graph. Let us move to the log graph. See this log space 2 power x graph, suppose for the 2 power x. Usually we are taking x axis and y axis. The scale is either zero point 0.1 or zero point 0.2 or 1 step size, whatever it may be. But the same curve we would like to draw in a log graph or anti-logarithm graph. So there are different types, right? So it is suppose the log graph. How you can visualize the log graph for this? Let us type the same thing. Suppose x is equal to log space. This is one of the syntax uh, to execute a vector, to define a vector. Y is equal to, usually we write 2 power x, right? The syntax is log of x comma y. Log of x comma y. See, once we run this, what we will get, what it will show. And let me give at every time clear all and CLC. Yes. It is showing error. What it means? Error using incorrect dimensions for given values and output values. And it is showing maybe this perform element wise matrix powers. Is right, because see, observe here, once I type x value, x is the vector, right? From 0 to 0 to 100, it is a vector x value. But once we are typing y is equal to 2 power x, so that means it is a element by element power. That's why we should take dot cap. If you are not giving a dot for the, because of x is a vector, that's why it is showing the error. Once we run this file, see here, now we will get a curve. This is, but we would like to make it the grid also to be appear here. That's why let us make a grid on. The remaining options are same. How do you assign the X label, Y label, the title, the legend, whatever I gave the demonstration for the starting basic ones. The same thing you can continue. This is a log of X comma Y. Is right. See, only along the X-axis you would like to make the log, and along the Y-axis you should take the normal step size. What is the syntax for that? So that is a semi-log X itself. This is right. See, you feel here, this is the curve actually. This is the semi-log x syntax. Only along the x-axis, how the scale we are taking, scale is visible here. And along y-axis, what about the scale here? Let me take for the same 2 power x, right? Why should we change? Let me take for this, sorry, semi-log x of x comma y. Let me run this file. And what it is appearing, see here, I will close and I'll see. This is what it is appearing along 0 to 14. See how it is appearing because of the scale we are not taking properly. That's why it is showing like this. So this is one example. If you are not taking the scale properly, the visualization is not proper, and it is a difficult to analyze how the curve to be. Okay, so for that, that's why let us take suppose a log x to give the example. I mean, I'm just simply taking a different curve. That's all. Nothing more changes here for this. See, this is log x. Or if you want to take the log y, let me close here. Semi log y. Only along y-axis, it will appear like this. See here. Along y-axis, logarithmic scale, and along x-axis, normal scale we are taking. So this is one of the technique for log. I mean the plotting, general plots, multiple curves. How you draw in the same, and multiple positions. How do you draw? And this is the log one. Okay. Let us move for the other one. What next? Function plots. See, till now, numerically we found, we give the x value. At certain x values, we found certain y value, and using those x and y, we have seen how to draw the plots, but without giving any x value. How do you draw for certain function? So for that, this is the syntax. Here, f plot at the rate of x, e power x, or sin x, simply you want, or log x if you want to take, or let us take suppose e power x, x plus sin x. It's a typical expression. Let us take. Then we see what we can observe in this. Let me block this. I mean, unhighlight that. Let us take suppose f is equal to. See, observe here. I'm using anonymous function file for this. As I wrote e power x plus sin x. Let us take the typical expression. Now for this, we would like to plot f plot of f. So this is the curve for that. And see, suppose I'll change the expression x square. Now see what changes we observe there. This is r x power 10. Let me take x power 10. This is r inside sign. Suppose inside exponential e power x by 10. Let me take and see what we observe here. E power x by 10. Yes, this is earlier it is a 10 power 10, right? Now it is a 10 power 6. Let me take suppose 10,000, then it will be reduced. This is once you change this, then you can feel the curve, a very simple curve. So this is one of the syntax. How do you draw a function easily without assigning any x value? Okay, and see what is the syntax exactly. See, observe here. Actually, the curve is, sorry, the function is a piecewise function. You know what piecewise function is? Nothing but a breaking function. F of x is equal to, actually it is given e power x and cos x. Within the range -3, 0 is e power x, and 0 to 3 is the cos x. Actually, this is the function. How we visualize this is the example, and this is the syntax for function plot. In the same graph, how we visualize this. Let us try the same thing, or sin x and cos x. Let us take. Then you feel exactly what it means. See, suppose f1 plot of, or let me take f1 is equal to sin x and f2 is equal to cos x. Okay, then f plot f1 Let us give the restriction for x values -3 to 0, it has to appear. So that's why it is like this. Actually, the function expression we have not given properly, right? Yeah, because anonymous expression is like this. Because the plot means, sorry, we are using the plot syntax means we are not giving any information about the x. I mean, we are not assigning x certain value. So that means taking anonymous expression like at the rate of x, it means that x is some symbolic variable. So that is that's why we are using anonymous expression for the sin x and cos x. Suppose -3 to 0. Next, hold on, f plot f2 and 0 to 3. Suppose this. Let us run this, and so what we get. I think it is appearing in the earlier curve itself. Let me close this and draw. Yeah, now it is the curve. Is right. Now you can give any color if you want. See, suppose this is blue. This is red. It is. And if you want to give increase the size or take the different fonts, also you can do the font. Different font. What it means is right. So this is how do you draw a function directly using the syntax f plot. Next, let us move to the next one. Function plot 3D. See, these are the curves, not surface or the contours or something else. So the function plot for 3D. For the same thing, see x values, y values, and what is the gt. Yeah, of course, this is actually the parametric representation. X is equal to sin t and y is equal to cos t and z is equal to t. So this is the parametric representation. And for this, let us move to the editor. X is equal to at the rate of the parameter t, suppose sine, actually theta we write manually, but theta symbol is not possible to type here, so that's why t you have taken here, or you consider t is itself as a parameter. Angle z is equal to at the rate of, suppose this is t itself. We don't want to exclude these files. Next, f plot 3. I mean the 3D plot x comma y comma. So let us see the graph. This is 3D plots. Or if you want to change, this is 3 times sin t. 3 times. Let me change. It is a 4 times, suppose. 3 times sin t and 4 times cos t. And see, observe what changes we are getting here. And see, once we got the 3D. But if you want to look this 3D in a different angle, how do you change? See up in top right, just click on this rotational, rotate 3D wise. Now click somewhere, hold, keep holding the curve, just drag the mouse and observe here how the curve should be. In a ellipse curve, right? And if you come to the 3D motion, see this is. So this is the advantage of visualizing a 3D expression of 3D visualization of any expression. See, in different angles, how the curve should be visualized. Is right. So these are the advantages visualizing the expression in 3D also. Next, data distribution plots. Data distribution plots regarding these, usually the statistics people, those statistical peoples are using these type of data to visualize. These are the syntax. See, observe here: histograms, scatter plots, pie charts. Let us see one by one. What is the histogram? What is the scatter plot? What is pie chart? And what are the different options available there? So this is the 2D and 3D in different dimensions. How do you visualize the histograms of certain data? See here, here executed certain data x is equal to random 10,000 of 1. Why we should take that? Let us take a simple one. Then we try with that. So this is to draw the histograms. Let me take x is equal to suppose 10,000 comma 1, right? 20, 30, 12, 15, 24, and suppose 21. Simply h is not required. Simply you can take histograms of x. That's all. Histogram of x data and histogram of x. See here, this is like this. Right. So actually x we have taken as rows, right? Let us make it the column. Then you see actually the column. Yeah. Histogram of x. This is not giving properly. Let me move. Let us take the random matrix itself. X is equal to random normally distributed. Random n is nothing but random normally distribution. So suppose let me take the 10 points itself, then run this file. Now see this. Only 3 different values we are getting in between this. Right? But I would like to increase number of histograms in between these. For that is the option directly simply the comma. Suppose 20 you would like to generate in between of them. See this is. And you would like to increase suppose 100. You make that. Step size is a decreasing for this case. Right? Or you would like to change the input format. See how it is. Histogram of x comma 10. Right? The same thing, suppose you would like to visualize in 3D. Simply the syntax is whatever the histogram syntax, at the end you just simply put 2, and we need to have the 2 dimensions, right? So that's why y is equal to random n of 100 comma 1 suppose. Then let us take x comma y and let us remove the number of histograms. First draw for histogram of x comma y. This is histogram of x comma y in 3 dimensions. And let me restrict suppose 30 histograms has to appear there. It is changing. Or only want to execute 5 histograms. Or 50 suppose you would like to. See this is. So this is how you can change, or that format is the same: x label, y label, and z label. How do you assign the x label and y label and z label? How do you give the title? The syntaxes are same. The same syntaxes you can use for all the histograms, log graphs, and the general plots also. Okay, so this is how you draw the next box chart. This is the another format. How do you draw the box chart? So these are the syntaxes. Y is equal to some data value. For that, simply giving a as 10 is nothing but magic, is nothing but one of the standard matrix syntax to generate a 10 by 10 matrix. That's why give 10. If you want to take, you take the random of 10 itself, no problem. There is no restriction. Now the syntax for that is a box chart. This is the syntax, box chart, and inside is the same whatever for what you are drawing the box chart by. Let us move. Suppose this is just like box chart. We need to have the square matrix for that. That's why suppose y is equal to magic of 20. Let me take now box chart of y. These are the huge values, so that's why we'll get a more number of box plots. Yeah, this is box. More number of plots. See, if suppose if you change only a 5 by 5 matrix, only 5 will be, is right. And by see whatever the underlines appearing here, these underlines, I mean horizontal cross, that represents median of the data. Here, what is the data actually? The data will be appear here. So actually, this is the data. The column wise 17, 23 is right. 17, 23, 4, 10, 11. For this, what is the median value? So at that median value, this horizontal line appears. The same way for the second one. So because of the data is a different data along the column. That's why it is showing the different places the horizontal line for different positions. Okay, so that is what it is a meaning of a graph chart. Sorry, box chart. And if you want to analyze differently the column wise and row wise, simply take this is sorry. This take y complement transpose. Then the syntax may be visible differently. This is, or earlier it is, see here with a y what it is, and with y transpose, that means row wise data. For that it is the box chart. See, however you want, either row wise or column wise, you can simply put in, because we know y is nothing but a matrix, simply putting a single quote, that is nothing but the transpose, is right. So that's why it is showing like that. It is next scatter plot. That means at every data point we have to visualize only dot or something else. So that is nothing but the scatter plot. See here what are the syntaxes. Linear space, usually this is actually 0 to 3 pi, right? You can write 0 to 3 pi actually, like this, x is equal to. But what is meant by linear space? This is the another syntax. In between 0 to 3 pi, we have to take the 200 points. At these 200 points, we have to find these y values, and for that x and y values, we have to draw the scatter of x, y. So this is actually what we are looking at, a scatter graph. Let us try the scatter graph for that. See that x is equal to, I don't take that many points, linear space 0 to suppose 2 pi. Let me take a 50 points simply. Y is equal to cos x is enough. Let me take the cos x and scatter of x comma y, right? Yeah. See what it is. This is, even for this also, if you want to change the color, you can change it, right? But see what are the syntaxes to change it. See, this length of x, s, z is, I mean the number of points if you would like to execute. And for that, this is the syntax actually. C is equal to line space of at every point. What is the size is checked. Simply take the size xy of Suppose let me take a 20. 20 is not showing much, is right. Let me take 30, suppose. Oh, I think it has to link with color, I think. C is equal line space, it should be filled. It is right. Linear space of 1 comma 10, whatever the length of x, then comma C, that should be filled. I mean, till now actually we are getting a circles, right? That circles to be filled with a different colors. So that is what the graph should be. Yeah, we are getting this. Is right. Why it is giving a line space 1 to 10 length of x means, see, as keep moving the x value, right? As keep moving x value, the colors need to be changed. This is like this. The colors need to be changed like this. See, keep observing, moving like this. The color is changing. So that's why we gave the syntax like this. So this is what the scatter plot. Next, the 3D, three-dimensional. How do you do this scatter plot? Right. See, first we are giving a restriction. Actually, would like to draw for sphere, or let me draw for the same sin t, cos t, and t. I mean the parametric curves, right? For the same curve, let us draw. Earlier, we took the same, right? Maybe this one. Let me take the same data. Let me close this. Now let us remove these eyelets. Yeah, 3 sin t, 4 cos t, and see now the scatter tree. Tree of x, y, z. Maybe the syntax wrong. Maybe yeah. Scatter tree of x, y, z. Okay. Numerical values we want, right? Not function plot. We are not looking the function plot. That's why it is giving the result like. Let us give the t is equal to, suppose, linear space 0 to 2 pi 100 points. Yeah. See, this is earlier whatever it has shown the same thing in 3D. But let us remove this C and see what it may be x, y, z. Let us take the 30 and C comma. Maybe this is the length of z, I think. So, see here. Right, so this is how do you draw the scatter plot. Okay. Next, 2D and 3D pie charts. Usually, if you'd like to analyze certain people performance percentage wise, or certain missions, suppose in laboratory there are 3 missions. We should like to analyze what about their performance, at what percentage we are getting the benefit from different missions. There are multiple missions. So using the pie chart, how do you make it up clear? And suppose the x values, we need the data of, suppose that is x is equal to, suppose 1, 3, 0 0.2, 0.5, 2. These just like, let us consider x is equal to the number of defective devices arised from first mission, 3 devices d and 0.5, I mean averagely 1/2 and averagely 2.5 and averagely 2 defective items are getting from certain missions. But those, how we can analyze those, and how do you visualize using the pie chart? So for that, see, this is another one, the pie chart. I thought the participants from various fields, so that's why I would like to cover all varieties of plotting options. So by that, whoever would like to you utilize these syntaxes wherever at different fields at different requirements, you can easily move on to this. So that's why with that aim, I try to demonstrate various options. What are the various options to visualize either two-dimensional or three-dimensional? Now see, what about this x is equal to 1, 3, 0 0.5, 2.5, and 2. So this is actually pie chart. But see, suppose if you'd like to divide one by one, and that is also, you can make it up. See, some part you would like to, that is explode. Explode the first one, you don't want, you would like to remove the second one. Let us make it all 1, 2, 3, 4, 5, right? 5. Oh, sorry, we have not included in syntax, right? So actually the syntax is x comma explode. Now use this is. But for different ones, you would like to give the label. What about this color? I mean, what it represents. What about these and what yellow and dark yellow and what about these pictures or represents one by one? You'd like to give the names for that. So that is how you can make it up. It's simply just, I think I gave the explanation earlier. It is nothing but a label. Labels is equal to this the syntax in inverted commas. Suppose this is for A, like this for B, and this is for C. Total 5, right? This is, now give the labels. This is, now here A, B, it's giving the name itself. And if you want to print directly, you can print the series. Simply take the print option. Or if you want to import data, you would like to save the workspace, is right? Or suppose is there any already generated graph? How do you open this? And there are different options in this. Yes, this is two-dimensional and three-dimensional plotter. Now let us move to the polar plots. Whatever the polar function, how do you visualize that? It is just like x is equal to, I mean, sorry, r is equal to sine theta, r is equal to cos theta. Those type, how do you visualize easily? It is just like suppose r is equal to cos theta graph. We try this one, r is equal to cos theta. And actually for this, the syntax is, it's very simple, the syntax, polar plot. But the first one is theta. Theta is the independent variable. R is dependent variable. It is just like x comma y, theta comma r. Okay. Let us move further. This is polar plot. Suppose T H E T A R. Simply let me take P. P is equal to suppose 0 to 2 pi. I mean one complete rotation, 0 to 2 pi, and rho is equal to, let me take cos theta. That means cos theta. Now what is the syntax for this polar plot? Sorry, P comma rho. See, this is the plot, polar plot. R is equal to cos theta. Let me change, suppose 1 plus cos t. It's a coordinate shape, I think. Is right. Or if you would like to make it 1 plus 3 into cos 3, what it represents. Is right. Next, suppose inside of the cosine, if it is a 2 times, what changes? Let's see here, 1 plus 3 cos 2t. And suppose I'll make 1 plus 6 cos 2t. It's clear how easily we are drawing, but manually to draw these polar plots, it's very difficult, but using a single syntax, a polar plot, T comma, or if you'd like to give the different colors also, you can give for this. I think I already gave what about the syntaxes, what are the different styles, what are the different markers, like the circle, a square, or plus, or star, whatever it may be, you'd like to make it the markers you'd like to make it. But there is another syntax to draw the polar plots is EZ polar. This is nothing but a function plot. Like we are not giving any t value for this. See here, this is that syntax. We are not giving any value for t, but it is showing. And this is for complex numbers. For the complex number, how do you draw the polar plot? I mean, these are just like a points, right? 2 plus 3i. 2 is the number real one, minus 1 plus 4i, 3 minus 4i. These are the just points. How do you represent a point using a polar plot? So these, let us move to the complex, suppose. Z is equal to, let me take my own 0, 3 and 1 plus 4i, minus 1 minus 4i. Okay, next suppose 3. So this. Now polar plot of Z. See, this is actually polar plot of Z. So it is just joining all the points one by one, 0 to 1 plus I and 3 on 1 plus 4i. So let us make like this. This is the circle only if you like to generate. Then it will give the property. It doesn't give any star, I mean any solid curve. See, suppose these are the points 1, I'll make it red color. Then it can visible properly, I think. Yes. Observe here. This is the point, and this is the point, and this is the point, and this is the point. By default, whatever the points given in a complex, that converts in terms of a polar form, and then giving graphical representation of those points. So that is using a polar plot. Similarly, EZ plot. EZ plot of, let me restrict this. Actually, we have EZ polar. Polar in inverted commas. Suppose let me take sine power 4 theta. Okay. EZ polar of sine power 4. See, this is what is sine power 4. Okay. Now let me change inside of the sine 2 times and see what the curve will be. This is the 4 dumbbells, and if you take the 4, you will get 8 dumbbells of that curve. See, this is. So this is how do you draw the polar curves in a different styles and for different expressions. Okay. Now next move to the 2D and 3D contour plots. And these are the important, I think, for the mechanical, chemical, civil engineering students, because computational wise they're handling with the maximum data. Sorry. It's around 11:30, but yeah, let us draw these contour plots. Contour plots means it is a two-dimensional. So that means we need to get the x and y. So x data we need to get and y data we need to get. But observe here, this is not like earlier. This is suppose x data and this is y data. But why we are making these? This means to draw actually we need to get the x and y axis, right? We are making the grid like this. Exactly at what points we are assigning the x value. Suppose this is the point and this is the point, this is the point. Let me take a different color, then you feel exactly what it is. Yeah, this is a different color. This is the different color. This is the different point. These are the different points, right? At these points, whatever the z value we assign, so that is actually it can be. That's why we should make clear what is the mesh grid to draw the contour plots either in 2D or 3D. So that is the advantage for these actually. Let us go for exactly what about these contour plots and what it means and how you can visualize the contour graphs. And for that, as I just explained, first let us take the x values. X is equal to a linear space, or if you like to execute from -2 and something. Okay, let us take the same linear space -2 pi, 2 into pi, comma 2 in, I mean -2 pi to 2 pi. Suppose the points are 100 in between of that, and y is equal to line space 0 to 2 pi. For this also 100 points. Now let us make the grid in between these two. It is a mesh, small letters. Mesh grid is the syntax to make the grid of x along x and y axis. Now actually the function is suppose a sin x and cos y into cos y, sin x into cos y. Now contour of x, y, z. Yes. Something is wrong. Maybe dot we have to take here. Yes. Now it will show the result. Okay. Here capital X and capital Y. So small x and small y are converting in terms of capital X and capital Y, right? So that's why it is. This is the curve. Sin x into cos y. See here, there are certain boxes. In each box, we are getting certain contours, is right? But the same thing, how do you visualize in 3D? Suppose the same curve you would like to visualize in 3D. Simply, it is a contour 3. Just see the curve. See what change we are getting here, is right? This is a 3D. But once I'll make like this, we are getting in 2-dimensional is clear. So that means you feel it. What about the 3D? What is mean by the contour? Whatever the 3D curve is like this. But looking this at certain angle like this, that is the contour actually. Right? So this is actually the 3D visualization of that. And we are looking at certain angle, how it appears, how it represents. So that is nothing but the contour. So in 2 dimensions, suppose the xy. But I would like to increase the number of lines, number of contour lines. Suppose at 10, I would like to make it. See what it gives in between the curve. The 10 means it's more, right? So that's why it is taking time. See here like this. Suppose I'll make 20. What changes we'll see here? I'll make 20. Just keep observe the graph. See the number of contour lines are increased. But suppose if you'd like to change the style, like dotted lines, if you'd like to make it, dotted lines, it will give. See, is right. And you would like to know what curve represents. I mean, what is the value for each curve? What is the value for each curve? It is like this. What is the value for each curve? So text on. This is also in single quotes. So text on. Let me take the solid only. Is right? This is. Let me increase suppose 8 number. Then once we run this for the solid curve, what it represents. This is. I mean, different contour lines. What is the value of that? For here, negative is right. For this case, this is a negative, and for this case, it is positive. And for this case, it is negative, and this case positive. This is a negative. Simply see what it is exactly. But see, suppose by by visualizing these with the data inside the graph itself, it is showing like this. But once you move to the 3D, I mean, three-dimensional graph, we have just seen what it represents. Let us remove this. Simply put, and you have to use a color bar. I mean, I try to visualize three-dimensionally the same behavior and observe here, whatever the color here representing, at the same point, that shows that color represents its value is minus 0.6. This yellow color means it is the positive value, it is about 0.8. That means this is. So the low value is a negative and higher value is a positive. In between, this is the 0. So accordingly, you can analyze using the color bar. What color contour line represents what value? Three-dimensionally for this case. So this is how you draw 3D contours and 2D contours. And what are the different? Even suppose if you'd like to increase the size of the contours. And for that, it's very simple. How do you visualize for that? This is it is just like let me see the contours. You can make it as this is one of the syntax because it is already made. It is inbuilt. Whatever the MATLAB language, accordingly we have to use it. We can't write our own syntaxes. C dot line width is equal to suppose 8. Let me take. Then see what we will get. For the contours, the size will be increased. Maybe 8 means it's less, I think. Oh, it's maximum. See, by increasing the size, if suppose let me take 4 itself, the thickness will be reduced. C dot line width. For different formats, there are different syntaxes. So this is, see how it is. And next, contour F. Let us see, let us use the same, suppose a contour F. What is meant by the contour F? Let me close this. Contour F of X, Y, Z. Let us close this, otherwise, yeah, contour F of X, Y, Z. So that means it's filling whatever the gap with the different colors. The contour F is nothing but filling in between the contour lines. It is showing the different color. So that is contour F syntax. That is what the benefit of the contour F. I think you can use in the same. I think we remove this, and here itself we use it, contour F. Then see what it means. M comma C contour F. We feel what exactly the thickness in that. See exactly. And even the one more syntax for that, contour 3 dimensional, of course. I've shown you just now what is the contour 3. I think line width, I'm not sure. Let us see. Yeah, this is in 3 dimensional. Okay, so this regarding the vector plots, I'm just giving the information here. What about the vector plots? What are the different syntaxes? There are syntaxes like QUIDER. This is one of the syntax for vector plots. Either the same vector plots you'd like to draw in a 3 dimensional, or streamlines. How do you draw this, right? Or if you'd like to visualize a gradient of certain scalar point function, use the gradient option and use these two syntaxes, contour of xyz and QUIDER. Or if you'd like to use, you can use streamline syntax itself in place of QUIDER. These are the vector plots. How do you visualize? I'll save the PPT, then accordingly you will come to know what are the various options. How do you draw the surface plots and geographical plots? I would like to visualize this geographical because it gives a nice information. See, suppose I think I give an example in certain area, how much percentage of the people are affected with certain disease. How do you visualize? How do you explain to the people graphically? I would like to take that LATSEATLE is equal to suppose 8 and LONSEATLE. I'm just typing whatever in the slides. So the LHS part, whatever you want, you can take. There is no restriction of taking the same thing, but the right hand side is the main requirement here. The syntax is geoplot. See, geoplot. Geoplot, LEAT. Okay. It's comma LEAT. Next. I would like to show you what is the advantage of this, so that's why I'll try to execute this. I run the file. It is taking time to visualize the graph. What is a geographical plot? It is loading. Yeah, see here. It is showing the India map, right? So over the India map, and this is the line actually from where to where we have drawn this line, straight line. This is. If you'd like to change it, you can change it like this. You can move the different place. It should be clear if you run these while connecting with the internet. Otherwise, it is a difficult of loading that whatever the image of geographical is. So this is how what is the benefit of geoplot syntax? How do you visualize the certain image geography? How do you visualize this? And from somewhere else, how do you make it certain points? So this is one of syntaxes to visualize. Now I would like to move to the differential equations. Of course, there are the different techniques. Differential equations numerically and analytically. How do you find analytical and numerically using a MATLAB software? I'll move to one of, I think there is another PPT for that. What I'm planned to explain for this, exactly. Yeah. So differentiation of functions, solving first order differential equations with conditions, without conditions. If suppose order is high, with condition, without condition. In the first order, solving system of equations with conditions and without conditions, the same in a matrix format. How do you find those? Is right? So see, this is the syntax actually. In MATLAB, differentiation of f comma x comma n. Observe here, this is actually the symbolic mathematics because the output is also in certain variable. So for that, I think the better let me take what it means. Live editor I'm taking here. So the syntax is actually differentiation of x. So first, let me yeah, x, and let us move to the problems. So sin x differentiation. Here x is a differentiation, right? Differentiation of f comma x. Suppose the function is, let me take a typical one, sin x into secant x by f is equal to sin x into secant x by square root of x cube, sorry, x cube plus 2. This is, I'll, so this is what the solution. But if you want to simplify the result, you can simplify. I mean, simplify syntax is, it's simply uh, to see what is the benefit of this. Earlier, what is the result and what about now? See, there are two different fonts, right? Differentiation of x. I will show you with the two different syntaxes. Differentiation of f. So this is right. These two results are same, but with simplification is this, and without simplification is this. So even the simplification also you can do using the MATLAB, using the simply syntax simplify of certain value. And for the same, if you'd like to make the fourth order, you can easily find out fourth order. See what you will get, the fourth order. So this is, and with the simplification, and this is the without simplification. Is right. So that is what the, how do you find differentiation? Of course, in last class I explained how do you find a differentiation, ordinary and partial derivative. Let us move to the differential equations exactly. And for that, what are differential equation of D-solve of equation? This is the syntax. D-solve of equation. Let us take find the solution of these analytically using a MATLAB software. So what is actually the equation? Y prime minus 2y by x plus 1 is equal to x plus 1 whole cube. That's why let us type first equation is equal to, okay? So dy by dx, differentiation of y comma x minus 2y by 1 plus x, right, is equal to x plus 1 cube. Observe here, actually there are two equal symbols in a same single line, in a single line. But when you come to the equation, this is a proper is equal to, the both sides should be the equal, right? This part. I'm making, I would like to clear because there the people are making mistakes usually. While typing here is equal to is nothing but a double equal to, we have to type in software, I mean the MATLAB software in this case. This is the equation. Now simply D solve equation. But see, usually we are taking x comma y is the symbol. This is the important. If suppose if you are not giving this, let us see, I'll remove and I'll execute. What you will get see here. Definitely dou y by dou x minus 2y by x plus 1. So this is equation. If you type that, what you will get see here. Of x. Right? Desolve equation. This is next. Suppose this is actually, let me take y is the right solution is equal to. Let me draw f plot of solution. Maybe is it in between quotes? Yeah, this is in between quotes. Otherwise, it doesn't appear. And one more thing, there are some arbitrary constants, right? Yeah, it is. So this is the curve. I mean random curve. This is a f plot of solution. This is okay. So the f plot is not required for this case. So this is the solution. How do you find the solution analytically using MATLAB software? Suppose there is a condition for this. How do you find the C1 value? I mean the arbitrary constant, right? For this case, this is the arbitrary constant. How do you find that constant? And for that, let us take certain problems. Dy by dx is equal to y minus x by y plus x. Equation is equal to differentiation of y with respect to x. I mean dy by dx is equal to y minus x by y plus x. This is the equation. Now what is the condition? Condition is equal to y of 0 is equal to 1. And this is the syntax for the solution. Solution is equal to Desolve equation comma condition. Symbolic solution right here. The symbol will repeat problem. Y of 0 is equal to 0. Everything is correct for this differentiation of y comma x, y minus x by y plus x. Condition y of 0 is equal to 1. That is also correct. Equation Desolve. What is the question? Unable to find a symbolic solution. Dy by dx is equal to y minus x by y plus x. Y of 0 is 1x0. Let me take the second function. I don't know why it is 1 by 1 plus x, right? For this it is getting, maybe the function is around for that. Now for this it is getting 1 plus log of x plus 1. There is no arbitrary constant, but for this case there is an arbitrary constant because here there is no condition. But here we are assigning certain condition, right? So that is the advantage in a single syntax is the only a single syntax, Desolve. We can easily find the solution if there is a possibility of analytical solution for that equation. Okay, if suppose the order is maximum, I mean more than one, let us go for the third one, the second order, right? D square x by dt square yes y ms. There actually independent variable is a t, right? And dependent variable is x. Equation is a first one is a d square x by dt square. That's why that is the syntax for that. Minus 2 dx by dt. Right? Minus 2 dx by dt. This is minus 2 dx by dt. Next, plus x is equal to e power t exponential. So this is the equation, right? Now condition, there are the two conditions. One is x of 0 is equal to 2. That is one condition. What is the another condition? That is the differentiation, right? So that's why let us move, suppose a dx. Sorry, differentiation of x comma t. First we are assigning certain variable for that, and now dx of 0 is equal to minus 1 here. Now use the solution syntax. Solve equation condition. Right? What is the condition here? Condition is nothing but there are two conditions. 1 and 2. There are two conditions. So that's why I gave the condition like this. See here. This is the solution. Right? 2 e power t plus t square e power t by 2 minus 3t e power t. Let us give the simplified syntax for this. What we get? Simplified solution. It's simply e power t has been taken common simply for these. What is the difference with the simplification? Is right? How simple it is. Whatever the order, how many number of conditions has been given, how easily you can find solution using MATLAB software analytically for the solution of the ordinary differential equations. Next, suppose the system of equations. See, this is the equation 1, equation 2. For the first equation, what are the conditions? For the second equation, what are the conditions? Let us move for that. This is suppose first one is a problem and second one is the another problem. This is one and this is the another problem. Dx by dt is equal to 5x plus y and dy by dt is equal to y minus 4x. Let us do the first one. And dx by dt, right? SYMS. How many dependent variables here? X and y both. Dependent variables are t. That's why x comma t, y comma t and t. These are the symbols. Equation 1 is equal to what is dx by dt, is right? Differentiation of x comma t is equal to 5x plus y, and equation 2 differentiation of y with respect to t is equal to, this is a y minus 4x. Now the solution is equal to equation 1, equation 2. This is the syntax. Is it appearing the solution? Observe carefully here, the right hand side, this is solution struct with fields. Y is equal to 1 by 1 symbol, x equal to 1 by 1 symbol. So that means here actually there are the two outputs because the two dependent variables, right? One for x and another one for y. That's why let us give the restriction in the output position itself. So the first one is a solution of x and a solution of y, suppose. Now you will get the solution for both easily. Here. Right? This is the solution of x and this is the solution of y. And of course it contains the arbitrary constants because there is no conditions for these equations. Once you assign the conditions, you will get the result very easily. I mean, without arbitrary constant, direct particular solution you will get using these syntaxes. So let us try that one of those 5x minus 2y, simply the 5x minus 2y. For the same equation, I will change plus 5x minus 2y is equal to 0. The second one is dy by dt plus 2x plus 2y. Plus 2x plus 2y. So is equal to 0. Now let us type the condition 1 is equal to, what is the condition 1? X is 0 and t is 0. So that means x of 0 is equal to 0. Next condition 2, y of 0 is equal to 0. Yeah. Now the conditions let us give for this. It's common condition 1 and condition 2. Now see for these you are getting 0, and let me change one of the initial condition. Just see what we will get. See, this is the solution. Keep changing the initial values for x, either x or y. See what the solution. This is the solution of x analytically, and this is the solution of y. System of equations, but you to find manually it takes much time. But using it's only around 5 lines. With a 5-line syntax, how we can easily find the solution using MATLAB software. But the same thing you'd like to find in a matrix form. That is also you can do it in a matrix form. See, suppose the same thing, how do you convert the matrix form of this? And then how do you find this? So that is the question here. Suppose this is the problem for the first problem. Actually, let me take the capital Y, a vector x comma y, suppose, is right. And this is nothing but dy by dt is equal to dx by dt by dy by dt. What is the first equation? Dx by dt is right. Dx by dt is equal to, remaining is the right hand side, suppose that t minus 5x plus 2y. Okay, sorry. We have to write a capital Y. This is. So what is mean by A means? This is A is a square matrix and Y means x comma y. This equation Y is suppose a 5 is right. This is minus 2, and for the second one this is a 2 and 1. Like that we should take it up. This is, or if you'd like to take all this to the right hand side, you can take it up. That is not a problem. So it is let me draw as simple as possible. See, suppose dy by dt is equal to ay plus b, where a is nothing but a coefficients of x and y, b is a constant. Now let me take a, what is the A matrix from this, and 5x minus 2y. So taking the right hand side, minus 5 to minus 2 minus 1. And what is the B? The constant matrix. Here t is right. So this is a t, and for this 0 is right. How we should make here? Y is nothing but the column matrix x y. That we should give clearly what it means. The same thing in a matrix form. Let us see how do you write in a program. What about these? In the matrix form, here the solution variables are x and y, and dependent variable is a t. Is right. I think here equation is nothing but differentiation of capital Y we are taking. Capital Y with respect to t is equal to a star capital Y plus b. This is what exactly is right. This is that dy by dt is equal to ay plus b. Now we have to assign what is the capital A, what is the capital Y, and what is the capital B. Capital Y is nothing but x comma y, x colon y, because a column matrix for that. This is a column matrix. Next, what is A? A square matrix -5 2, next row -2 -1, is right. Next B, constant matrix P colon 0. This is, and for this there are the conditions, right? So the conditions, how do you give the conditions? For the condition also you have to give like this, x of 0, let me take, this is not proper. Condition 1 is equal to x of 0. What is the x of 0? I think we have to give y of 0, yeah. We are defining a new variable, right? The condition is y of 0 is equal to, see what is the 0 and 0, for 0 and 0 it is not getting, right, 1 0. Now this is clear. Sorry, let me take double equal to here. Now solve equation and condition. Will we get the solution? Let us try. Right, because we should give two different executions, solution of x and solution of y. This is, so I think better we simplify the solution. Simplify solution of x, same simplify solution of y. Then what will get? Right, this is the solution of x and this is the solution. Okay, now let us draw both. What is f plot of x? Hold on. F plot of solution of y. I think for y it is not showing solution of x. Maybe some, because of the no, there is no arbitrary constants for this, right? Maybe the visualization may be wrong. I think for this f plot will not accept character vector. Okay, if you assign the t values directly, you can draw for exactly these x and y. You can easily draw for this. I don't know exactly, but the same is the syntax. Maybe let me see the function. The analytical function includes some special functions like error function, Bessel functions, and there are some irrational values, right? So that's why the graph is not visible properly. Suppose the system of equation is a nice one and it will give analytical solution properly, then it is easy to visualize these things. So this is actually how do you find solution analytically. And I think today I demonstrated how do you draw the plots in various formats, like the line plots, logarithmic plots, bar plots, histogram plots, and this what about this the contour graphs, and in three-dimensional how do you draw, how do you assign the x label and y label, how do you draw the multiple curves in a single graph, or how do you make in a subplots, how do you save the file, what are the different formats available. And then next, in three-dimensional there are various it's like a streamlines, contour plots, surface plots, gradient, how do you visualize, and geographical plots, how do you draw it. And next I demonstrated how do you find the solution of a differential equation analytically. Actually I planned to show the numerically also how do you find, but for the being of time, it's not possible to explain much. Of course, you know that the software means MATLAB, especially it is a ocean to learn the knowledge. It is a ocean. Don't think I should learn the complete information about the MATLAB. You can't. Your life is not sufficient to learn. Whatever you require, that you try to learn and you try to execute. That is what I would like to suggest. But in future also, if you'd like to need any help regarding this MATLAB or any syntaxes or somewhere else the program is breaking, it's not giving the proper result, I'm ready to help. I'm ready to collaborate also. I think actually recently I started uploading certain MATLAB related programs or certain information in YouTube. This is my YouTube channel actually. This is Math Knowledge by Mallikarjuna. Those who would like to go through it, you can go through, or if you'd like to get the alerts, you can subscribe and you can move it. That's, and now over to the organizers.
Thank you, sir, for the lecture. Excellent lecture.
Yes, yes,
So, like we have two questions.
yes,
The
yes,
first
please.
one is the syntax of desolve. Do we need to define variables?
Yeah, we have to define. See, without defining the variables, how the system will consider which one is the dependent variable, which one is the dependent variable. That's not big. The people can easily understand, but this computer means it's a robot, right? We have to give the proper instructions to that.
Yes,
Which
sir.
one that will take the dependent and independent variable? That is thing. Next,
The vector and geographic plot.
okay. Oh, you would like to explain that vector and geographical plot. Actually, geographical plot, I have shown that. The vector plot means I gave the syntax. You try to execute the same. Let me see where I'm sure exactly. Polar plot. Yeah, this is a vector plot. Okay, I'll show the first one. Maybe for the week of time, it's what I call. Let me show the first one. See, suppose x comma y is equal to. I told you you have to give the mesquite for x and y values. It is 0.221 and 0.2. Sorry. Then u is equal to suppose certain function cos x. Y we are getting dot star y means y is the vector here and v is equal to sin x dot star. U comma v. Let us run this. It is taking time to, yeah, this is vector plot, how it should be. Even for the same thing, simply a Q or 3. You can draw the three-dimensional vector plot for this. See, this is the three-dimensional. And even for us, streamlines and other things also you can practice using the same syntax, whatever I'm giving here.
Yes, sir.
Yes,
We
yes,
have another
next.
question.
Yes.
For the system of nonlinear differential equation, is there any syntax to solve differential equation?
There are various syntaxes ODE 45, PVP 4C. I think I don't know what you are trying. I mean, initial value problem or boundary value problem. If boundary value problem means BVP 4C, that is the nice syntax which one will give a result more accurately. BVP 4C. Or if suppose it is initial value problem means you can go for ODE 45, ODE 34. There are so many syntaxes available. Yes.
That's also queries.
Okay. So actually the question from Vishnu is, I think, why we took matrix form for A and B. So that is another way of finding a solution, and there is no restriction why we are taking a matrix form. If you feel that is a flexible, you can continue, or directly you would like to find out means you can find out. There is no restriction. Just I gave it what are the different options to them. That's all.
Yes, so another question is like without line space and mesh grid, can we plot scatter?
Yeah, you can. I told you, right, line space is only syntax. See, just now see for this, recently I have drawn the vector plot, right? This is actually 0, 0.1. The same thing, suppose that caplex is equal to, I will take a linear space. Linear space from 0 to 1, 20 points, suppose. Similarly, y is equal to linear space 0 to 1, 20 points. Okay, so the simply actually in place of that I'll try to give I'll give what is a caplex and what is capital. Same thing, caplex and capital Y. Caplex is nothing but linear spaces, right? And capital Y is nothing but linear space. Simply running will get the same vector form. You can draw it. See, this is using a linear space. It depends on how many number of points you are taking in between these two. If you'd like to make
Okay,
only
phase
10
20.
means you can get it. Yeah, this is 10. See, the number of vectors will be reduced in the graph. Yeah, it is like this. You can draw without lane space also. Yes, next.
Yes, so so these are the questions we have for
Yeah,
today.
sure, sure. Thank you. I told you misgrid, actually one of the participants raised, Vishnu says, what is a misgrid? A misgrid means this is one of the syntax we are assigning to draw the contours. See, to draw the plot, why we have to take PLOT? Why not we take a plotting PLOTTING? So that means actually that is the syntax the people developed and fixed in the MATLAB software. To draw the contour graph means first whatever the x and y, it is just like a scaling along the x-axis, along y-axis, and both we are merging in a grid size. So that's why that is one of the syntax to draw contours, streamlines, vector plots, and all. Yes, yes, sir. One more. Is there anything?
Like we can end the session, sir.
Yeah, yes, sure, sure, definitely. And once again, thanks to the organizers for giving me this valuable opportunity. I would like to know the right feedback. I mean, how the participants are benefited from my lectures. Is there any mistakes or something else from the feedback? There is a chance of revising my lecture or some content. Definitely, I'll do. I'll try to polish my knowledge every time according to the feedback. That is what my nature, and I hope in future also I'll get more opportunities from this organization.
Yeah,
And
sure,
once
sir.
again, congrats to the organizers for conducting a nice program.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah,
Thank you, sir. Thank you very much, sir.
thank you, Razu. Thank you.
No bad feedback, sir. Everyone has listening.
Yeah, yeah.
The anxiety, sir.
Yeah, they are purposefully participating means
Uh,
they are concentrating. Yes, you are right.
yeah, yeah, sir. Yes, sir.
Okay, nice.
We are verifying, sir. The most of the time, minimum 35
Yeah,
to 40, sir. It is not reduced
okay.
below that. From starting of the class to ending of the class.
Yes, yes. Nice, nice to
Yes,
hear
yes.
that. Okay, so shall we stop, Raju?
Uh, if anyone, if participants
No.
can ask directly,
Yeah,
right?
yeah.
You
You
can
can
unmute and then
raise
you can
any.
ask if you want
Yeah,
to
you can
interact with us,
raise.
sir. If
Yeah.
you want to interact with
Otherwise,
us.
if you want to ping any doubts, you can ping this
Yeah,
uh,
yeah.
mail ID. I just presenting mail IDs here. Just thank you once again. Thanks.
Okay.